Hydrogen. Beta, hydrogen is the first element of your periodic table. Its atomic number is 1 and mass number is approximately 1, or it's 1.0078. So you can take it as approximately 1. Hydrogen is in the modern periodic table. Means they considered atomic number as the base of arrangement of elements. So since hydrogen have one atom, one electron in its outermost shell or in its complete shell, so that is why it's placed as the first position on the periodic table. All right. So let's start with the position of hydrogen atom in the periodic table. So hydrogen is the first element in the periodic table. It has resemblance to alkali metals, which loses one electrons and form unipositive ion. Hydrogen has a resemblance to alkali metal. What is the property of alkali metal? That alkali metal can donate one electron because they have one unpaired electron in its outermost shell, that is S, first shell means S shell. So they can donate one electron and become unipositive. एक electron donate करके एक positive charge acquire करते हैं. Same, it somehow its property resembles with halogen also. Halogen means your fluorine family. Fluorine, chlorine, bromine, iodine. How? Because when it's gain one electron, it forms a uni-negative ion. So I'm just going to give you example where it forms uni-positive and where it forms the uni-negative. So when hydrogen react with the non-metals or hydrogen donate it electron, it forms uni-positive ion. Uni matlab one positive ion. Okay. And when hydrogen accept the electron, when it react with the more stable or more reactive metals, so at that time that more reactive element force the hydrogen to accept the electron, है ना भाई. बाकी सबसे तो हाइड्रोजन मेटलिक प्रॉपर्टी है डोनेशन की, तो ये ज्यादा स्ट्रॉन्ग है तो डोनेट करेगा. लेकिन कभी कभी क्या होता है जब हाइड्रोजन आपके मोर स्टेबल मेटल्स के साथ रिएक्ट करता है तो व्हाट हैपन, तो मोर स्टेबल मतलब ज्यादा ताकतवर, तो वो हाइड्रोजन को मजबूर कर देंगे कि एट दैट टाइम हाइड्रोजन हैव टू एक्सेप्ट द इलेक्ट्रॉन इंस्टेड ऑफ डोनेटिंग. So at that point of time, it will form a uni-negative ion. Clear? Hydrogen form oxides, halides, and sulfides. So hydrogen has unique property. Then it can form oxides. For example, this H2O, and halides, LiH. Okay. Next, sulfide also. However, unlike alkali metals, it has a very high ionization enthalpy and does not possess metallic character under the normal condition. So its ionization enthalpy is very high. So because of that, it does not possess the metallic character. What is the metallic character? That metals are solid, lustrous, shiny, sonorous, malleable, ductile. So being it is a gas but placed in at the side of metal in periodic table. Okay, so it does not acquire any of the metallic character when the conditions are normal. But if you change STP means if you have standard temperature and pressure, then you can change its properties. And at that time it resembles some with the sum of the property of metals. Like halogens, it form a diatomic molecule. Your halogens means all gases. Generally in gases we have, in halogens we have gases. So to acquire a stable state, they just combine with each other and form a diatomic. For example, Cl2, O2, N2, and F2. So these are the examples of diatomics. So like the halogens, the hydrogen exists in H2 form, hydrogen molecule form. Combine with the element to form hydrides and large number of covalent compounds. However, in terms of reactivity, it is very low as compared to the halogens. So it can combine with the other elements and form hydrides and some other stable compounds, which have covalent character. So that is why it's in terms of reactivity, if you want to compare, so it is very low as compared to halogens because halogens are highly electronegative. So on the basis of reactivity, it is quite lower than halogens. As you can see in the periodic table, this is the halogen family, the 17th group, and this is your hydrogen. Being in the periodic table, it's placed at the first position, but as you can see, there is a difference. There is a distance between the first and this third element. Why? Because it is placed on the side of alkali metals because of its electron donate property, because of its electronic configuration, but it does not resemble with any other property of alkali metals, है ना? So that is why इसको periodic table में अलग से रखा जाता है, बिल्कुल separate. And this is the single element which is placed separately in the periodic table. Others are in the combined periodic table, full-fledged periodic table. Okay. Let's just talk about the existence of hydrogen. So your hydrogen exists in three isotopic forms. First is the protonium, second one is the deuterium, and third one is the tritium. Okay, these isotopes differ from one another in respect to the presence of neutrons. Ordinary hydrogen's protonium has new neutron, but this is the single element. This is the single element in entire periodic table which do not possess any neutron. If we talk about a normal hydrogen atom, so it is considered to be as protonium, which has one atomic mass and one atomic number. So it does not contain any neutron. But in case of two other isotopes, in deuterium and tritium, दोनों में क्या होंगे, आपके न्यूट्रॉन्स ऐड हो जाते हैं, इसीलिए मास नंबर बढ़ जाता है, बट एटॉमिक नंबर सेम रहेगा. सब में देखो एटॉमिक नंबर इज 111, but mass number is here in deuterium 2, in tritium the mass number is 3. So mass number changes because of the increased number of neutrons in the nucleus. Clear? So that is why these are considered to be as the you can say heavy hydrogen as compared to the plutonium.
Okay, ma'am.
So all these isotopes, only titanium is radioactive and emits low energy particles that are beta particles. I think you all are familiar with alpha particles, gamma rays, cathode rays. In the in the discovery of electron, proton, neutron, you have learned about these types of particles: alpha particles, beta particles. So deuterium has the capability, or it's considered to be as the radioactive element, and it can emit a low source of energy, that is beta particle. Since the isotopes have the same electronic configuration, they have almost the same chemical properties. The only difference is in their rate of reaction, mainly due to their different enthalpy of bond dissociation energy. So क्या होगा? Means although electronic configuration is same, if we talk about the electronic configuration, it means at that time we are talking about the electron distribution in the orbitals, है ना? हम जब इलेक्ट्रॉन डिस्ट्रीब्यूशन की बात करते हैं, तो since all the three isotopes have one electron in their outermost shell, so that is why the electronic configuration of all the isotopes will be same, which results in the similar chemical properties. Chemical properties is because of the electronic configuration, है ना? हमारा electrons decide करते हैं कि भाई उसकी chemical properties कैसी होंगी. If all the three isotopes have same electronic configuration, तो उनकी जो chemical properties होंगी, they will be nearly similar to each other. Okay, because of electronic configuration, since all of them have one electron in their outermost shell. So the only difference is in their rate of reaction. The main difference is chemically they react with the other elements like at same extent, but the rate of reaction will be different. Rate of reaction means speed of the reaction. If we talk about the tritium being a radioactive element, it just reacts spontaneously. If we talk about the others, so comparatively there will be a difference in the rate of reaction. So one can perform reaction very fast. Others reaction will be slow. Others reaction may be moderate or slowest one. Okay, this is due to the difference on their enthalpy of bond dissociation. Okay. Let's talk about the hydrides. What are hydrides? Whenever hydrogen combine with the other elements in normal condition, it can form hydrides, except noble gases. it can combine with each and every element present in your periodic table. हमारे एटमॉस्फेयर में, अर्थ में, कहीं पर भी कोई भी एलिमेंट हो, हर किसी के साथ हाइड्रोजन कैन कंबाइन. In some reaction it can donate the electron, and with some in combination with the others it can accept the electron. But the main thing is it can combine except the noble gases. Noble gases means helium, argon, krypton. Because why? Because they do not require any electron, their octet is complete. Okay, so dihydrogen under certain conditions combines with almost all elements except noble gases to form binary compounds called hydrides. Clear? So it can combine and form hydrides. These hydrides are classified into three categories. There are three types of hydrides on the basis of their combination, on the basis of the bond which exists between those binary molecules. Binary matlab two, molecule matlab simple a molecule. Molecule kab banta hai? When an atom combine together, two atoms combine together, they will form a molecule. And when more than 2-3 elements combine together, they will form compound. ठीक है? तो bimolecular means when two different element, for example H2O, hydrogen is different, oxygen is different, combinedly this is known as a molecule. Okay, so on the basis of the bond formation, on the basis of the force of attraction that exists between hydrogen and the combining atom, your hydrides are classified into three categories. First one is ionic or saline or salt like hydrides. Why they compare ionic with salt and saline? Because ionic bond is present in salts. Common example NaCl, where the elements combined with the ionic bond, they have the property to dissolve in liquid effectively. आप नमक डालो पानी में, disappear हो जाएगा थोड़ी देर में. It will get disappear. Why? Because the NaCl will dissociate into Na positive and Cl negative. Okay. So in these type of hydrides, ionic bond is present. Let's just move to the second one, the covalent or molecular hydride. In these types of hydride, covalent bond is formed between the hydrogen and the attached species. Third hydride is the metallic and non-stoichiometric hydrides. When the metallic bond is present between the hydrogen and the combining species, the metallic hydride will form. Clear? Let's just start with the ionic or saline hydrides or salt-like hydrides. So compounds of dihydrogen formed with most of S block elements which are highly electropositive in character. So these types of compound are formed when hydrogen, your dihydrogen, react with the most or highly electropositive elements. So they will form what? They will form ionic hydrides. Okay. The lighter metals hydrides such as LiH, BeH2 and MgH2. See, here the hydrogen is combining with the metals only. Now, if someone asks you that what will be the oxidation number of hydrogen in LiH, so this will be -1. Oxidation number of Li will be +1. Same with Be, same with Mg. So oxidation number changes accordingly when it reacts with the metals and non-metals. Since with metals, it accepts the electron, higher metals or highly electropositive metals, but with non-metals, it donates its electron. Okay. So in fact, the BeH2 and MgH2 are polymeric in structure. So the ionic hydrides are crystalline, non-volatile and non-conductive in solid state. So क्या होता है? These types of ionic hydrides, they have the property of crystality. Crystal मतलब उनके proper sharp crystal बनेंगे. अगर कभी हम नमक को बिल्कुल बारीक भी पीस देंगे ना, बिल्कुल बारीक फाइन पाउडर भी कोशिश करोगे, तब भी when you take a pinch in between your fingers, आप अपनी उंगलियों के बीच में उसको लेके रब करोगे, तो आपको वो पाउडर वाली स्मूथ फीलिंग नहीं आएगी, है ना? Because you can't convert a crystalline solid into a pure powder. वो छोटे टुकड़ों में जरूर टूट जाएगा, लेकिन फाइन पाउडर कभी नहीं बनेगा. ठीक है? तो क्या होता है? आयनिक प्रॉपर्टीज और आयनिक हाइड्राइड्स इज दैट प्रॉपर्टी which led to the formation of crystals. दूसरा, they are non volatile, non active actually under normal condition and non conducting in solid state. अगर solid state में होंगे then they will not conduct electricity. अब मैं आपसे बोलूं, take a bunch means take a fist of salt. आप एक मुट्ठी भर नमक लीजिए, उसको थोड़ा पानी में मिला दीजिए, थोड़ा आप साइड में रख दीजिए ऐसे। अगर हम वाटर में से अपने सर्किट के वायर्स को डालेंगे तो हमारा बल्ब ग्लो करेगा। क्यों? क्योंकि सॉल्ट वाटर इज द बेस्ट कंडक्टर ऑफ इलेक्ट्रिसिटी, बट व्हेन सॉल्ट इज इन डिसॉल्व स्टेट। बट अगर हम क्या करें, NaCl लें और उसके सॉलिड सॉलिड NaCl के डब्बे में हम अपने वायर्स को डाल दें, दोनों एंड्स को, क्या वो सर्किट कंप्लीट होगा? नो, because in solid state electricity flow through the electrons which NaCl don't have, free electrons NaCl don't have, so they can conduct the electricity only in the liquid state or dissolved state. However, they melt, conduct electricity on electrolysis, liberate dihydrogen gas at anode, which confirms the existence of H positive ion. So what happened if you just dissolve these hydrides into the water or in some solvent and pass the electricity, do the electrolysis process, so your hydrogen gas will evolve out from the anode. Why anode? Because in 8th class I think you have studied this thing, electrolysis of water. व्हाट हैपन, हम जब पानी बॉईल करते हैं और उसके अंदर इलेक्ट्रोड डालते हैं तो क्या होगा? भाप निकलने शुरू होंगे, द स्टीम विल स्टार्ट कमिंग आउट. दैट स्टीम इज नॉट एक्चुअली जस्ट वाटर वेपर, it as means along with water your gases are coming out of the system. So from the positive end negative gas will come out and from the negative end your positive gas will come out. ठीक है? And that shows the presence of hydrogen. How you can detect the evolution of hydrogen? हम कैसे डिटेक्ट करेंगे कि हाइड्रोजन इज इवॉल्विंग आउट? व्हेन यू कलेक्ट दिस गैस इन अ टेस्ट ट्यूब, है ना, and put a matchstick over it, it will burn with a pop-up sound. That just shows the presence of hydrogen. Okay, test of hydrogen. Saline hydrides react voluntarily with water producing dihydrogen gas. So when your saline hydrides react, they lead to evolution of hydrogen gas. Every time whenever your saline hydride react or ionic hydride react, your hydrogen will evolve out of the system. Lithium hydride is rather unreactive at moderate temperature with O2 and Cl2. It is therefore used in the synthesis of other useful hydrides. So what happens if we talk about the lithium hydride? So at under normal temperature and conditions, your lithium hydride will not react with oxygen and chlorine. Matlab, it does not react with the halogens. Why? Because that is, lithium is very strong, electropositive, highly electropositive metal. Okay, it reacts it with the hydrogen, is combined with the hydrogen. So to break that bond between the lithium and hydrogen, we require specific condition or the most electronegative element. For example, fluorine. Clear? It can, the fluorine can react with them, but it will not react with oxygen and chlorine because they are least electronegative than the lithium. Electropositivity of lithium is very high, and comparatively, electronegativity of oxygen and chlorine is quite less as compared to the others. So the LiH will not react with oxygen and chlorine under normal condition, but yes, if you change the condition, if you control the temperature and pressure, they both can react with LiH and hydrogen. Evolution will take place. Clear?